talk about inverse functions. Essentially what an inverse function is it is a function that is reflected over the y equals x axis. Now what does that mean? If I was to draw a line, let's just say through these points, right? Y equals x, so no intercept, no y-intercept's at 0, and my slope is 1 up 1 over 1, right? It looks something like this. And this is going to be our reflection point. So, for example, let's deal with this first one here real quick. So we have y equals 2x plus 4. Again, the name of it is inverse. So when I think of inverse, I think of flipping, which is essentially how you solve these. What I want to do is I'm going to flip-flop x and y. So the new equation is now x equals 2y plus 4. That's the inverse. That's it. Now, obviously, we can't leave it like this, though, because you'd never really see graphs shown where the output and the input are flip-flopped, right? Again, functions are vending machines where our y value is what we get out and our x value is what we get in. So we always have to have it set equal to our output value. So the way that we're going to do that is we're going to just solve back for y. So I'm going to subtract 4 from both sides. That's going to give me x minus 4 is equal to 2y. Now I'm going to divide by 2 everywhere. And that's ultimately going to give me y is equal to 1/2 x minus 2. And the way that we usually show the inverse is by putting this -1 exponent right here. That shows inverse function. So what I'm going to do here is I'm going to graph both of these and kind of show you the relationship. So y equals 2x plus 4. I'm going to go up 4 right here. I have a slope of 2, so up 2 over 1, just like this. And then I'm going to draw my line directly through it. So let's just go like this, for example. Perfect. Okay, that is my line. Now let's do this one as well. So if I draw this line, I have my y-intercept at -2. It is up 1 over 2 this time. Okay, so up 1 over 2. And right here real quick, let me draw my line here. Something like that. And then the last thing I'm going to do here is, let me make a different line. Let's make this red. And I'm going to have this line perfectly going through these points right here. And notice that reflection. See how it looks like a mirror image? That is the definition of an inverse function. Another thing that's cool about them is if you want to graph it, right, and you don't want to actually solve it out and graph it or anything like that, the points are genuinely flip-flopped from each other. So, for example, if we look at this point here, this point is 0, 4. And then if I look at my inverse function, I have a point here at 4, 0. And in fact, every single point on both of these lines have the same value, where they're literally flip-flopped. So let's just do this one, for example, because that's the other point that I have. So I have 1, 6. And so if I look over here, there's going to be a point. Obviously, this isn't perfect because I'm the one that drew it. But the main idea here is there's supposed to be a point here at 6, 1. Every single point are mirror images of each other, just simply flip-flopped. So, with that being said, let's continue solving the rest of these with that idea. So y equals x plus 4 over x plus 6. This one's a little bit trickier, right? Because I have x values at the top and bottom. But the idea is still the same. X is equal to y plus 4 over y plus 6. Now, here's a little tricky because I'm trying to solve for y, but not only do I have y in two places, I have it in the numerator and the denominator. So my first plan of action is to get it out of the denominator. So the way that I'm going to do that is I am going to clear the denominator by multiplying it. Now I do that on both sides. Multiplying the denominator by itself, just like this, cancels it out. And then I'm going to distribute the x to both terms. So y times x is just yx plus 6 times y is 6, or 6 times x is 6x, sorry, is equal to y plus 4. Perfect. Okay, now the next issue here is I have y in 2 places. So anytime you have a variable in 2 places that you're trying to solve for, get all those variables on one side of the equation. So I'm going to subtract y from both sides. And then I'm going to subtract 6x to the other side, giving me yx minus y is equal to 4 minus 6x. Last thing I'm going to do here, I have y terms in both of these. That means I can undistribute. So the same way that I multiplied x to both terms like this, I can divide out y from both terms. So if I divide out y from yx, it just leaves an x. If I divide out y from y, that just leaves a 1, is equal to 4 minus 6x. Okay, let me delete all this real quick. Now last thing here, I am going to divide both sides by the x minus 1. Let me just go all the way around like this, and that's going to give me y inverse, so negative 1 is equal to 4 minus 6x divided by x minus 1. And that finishes that one out. The last one here, we have the cube root of x plus 4 minus 8. Again, idea is still the same. It doesn't matter what type of function you have. So in this case here, x is equal to the square root of 3y plus 4 minus 8. I'm going to add 8 to both sides. Okay. X plus 8 is equal to the cube root of y plus 4. How do I undo the cube root? Well, the opposite of taking the cube root is cubing it. So I'm going to cube everything. That is going to essentially give me, right here, y plus 4 is equal to x plus 8 cubed. And then finally, I'm going to subtract 4 from both sides. Give me a final answer of the inverse of y equaling x plus 8 cubed minus 4. And that's it, guys. If you want any more questions done for you guys, feel free to go to my website at MindLeap Tutor. From there, you can go to the math resources, then video archive, scroll to the bottom, and there will be a section there to post your questions. But until then, I'll see you guys next time.